Hello, and welcome to Science from a Half-Built Shed. There we are, a beautiful sign. It's been made by Poppy and Matilda. Make sure you check out the Google class code, which is in this corner here. And if you want to join the class properly, you need to go to your Google Classroom home screen, click the plus in the top right corner, click on join and enter that code there. Right, in the trailer I showed you this rock and two other bits of rock that I picked up from the ground. They're all limestone, and I said we were going to do an experiment on them, and we're going to do that now. So I'm going to start off with cardboard and the cheese grater. And I did say this rock was quite soft, and we named it, didn't we? This is chalk, and I'm actually going to grate it with a cheese grater. And here we have chalk dust. So, I'll put that there so you can see it clearly. I'm going to add to the chalk dust some vinegar. A few drops. And hopefully you can see that it's bubbling up and it looks like a solid layer, but if I move it round you'll be able to see that it's actually giving off loads of bubbles. That means that the limestone or the chalk dust is reacting with the vinegar and giving off bubbles, which means it's giving off a gas. Let's try that again. But this time, instead of using vinegar, I'm going to cut open this lemon and use lemon juice. Now those of you that are smart will know the connection between vinegar and lemon juice. Here we are. They are of course both acids. So what I'm doing here is I'm reacting the chalk dust with acids. So let's try it with lemon juice. Oh yes, that's giving off bubbles more quickly. The bubbles are slightly bigger. It's a quicker reaction. We could say the rate of reaction is higher with the lemon juice compared to the vinegar. So this is the experiment that we are going to investigate. Now before we do, I should tell you the proper chemical name of the molecule of which this is made. It is calcium carbonate. And the formula is CaCO3, which means in every molecule of the chalk dust, the calcium carbonate, there is one atom of calcium, one atom of carbon, and 3 atoms of oxygen. So, what are we going to do in this experiment? Well, we're going to investigate the rate of reaction and we add the calcium carbonate to an acid. Now actually, I'm not going to use vinegar or lemon juice. I went into the science lab at school and I picked up some of this stuff. This is a much stronger acid. Obviously you can drink lemon juice and you can eat, or even if you'd like to, although I wouldn't recommend it, drink a little bit of vinegar, but you can't drink this. This is hydrochloric acid, 1 molar, which is much stronger acid than either of those. So we're going to be using that. We're also going to be using some glassware. I've got some conical flasks and some boiling tubes in a test tube rack, and somehow we've got to get this into there. So to do that we're going to need to smash up this rock. So I'm going to hand this over to Poppy now she's going to get smashing. And here Poppy is. Got her goggles on, got the hammer, got the big gloves. Nice. Smaller than that, Poppy. It's got to fit into the boiling tube. Cool. Yeah, other piece. Okay, I think that'll do. Thank you very much, Poppy. Okay, so Poppy has smashed up the limestone. Now I actually want it ground up even smaller, so I'm going to give you this pestle and mortar, Poppy. If you could take a handful of that. Thank you very much. If you go into the other side of the garden and you smash that up, we'll keep that there for spares, I think. Now Poppy's grinding up the small chunks of limestone into a powder, into chalk dust, and we're going to compare the reaction with the acid of chunks of limestone with actual limestone dust. Now, that's because what I'm teaching you about today is the rate of reaction and how the size of particles affect the rate of reaction. So we're looking at the rate of reaction when we change the particle size. Now to do that, we obviously need particles of different size, but we're going to keep the strength of the acid the same. Now I need to do a bit of teaching. If you're going to understand this, you need to know some things about how reactions occur. So the calcium carbonate, along with them, the calcium carbonate molecules are going to react with the hydrochloric acid molecules. Hydrochloric acid chemical name HCl. So the calcium carbonate molecule reacting with the hydrochloric acid, which is dissolved in water, is a solution. The reaction will only occur when the hydrochloric acid particles actually come into contact with the calcium carbonate molecule. That can only happen at the surface of the calcium carbonate particle. Now to really understand this, it will help if you had a good concept of how small atoms and molecules really are. And if you go to the Google Classroom, there's a couple of YouTube videos that are in the classroom there waiting for you to watch, and they'll explain just how small atoms and molecules really are. Sorry about the banging, Poppy's working on the limestone, smashing it up right now. To try and explain this, let's imagine this Rubik's Cube. And somebody out there might recognise this Rubik's Cube, although obviously they all look the same. I did confiscate a Rubik's Cube from someone several months ago, and it was still in my office drawer, so apologies if that was you. Yes, this is your Rubik's Cube. Okay, so if this Rubik's Cube was made of calcium carbonate molecules, then only the calcium carbonate molecules on the outside that come into contact with the acid particles will have a reaction. So one way to speed up the reaction is to make sure there's more of the outside. So look at this. If I oops. If I took the Rubik's Cube apart, you can see that now every piece of the Rubik's Cube, so just wearing a piece back, I've got Matilda there, thank you Matilda. Every piece of the Rubik's Cube has now got 6 sides of surface that are on the outside. So I've increased the amount of surface, or the surface area. Let me give you another example. Now one of my daughters, who's currently smashing up a rock over there, very kindly prepared this for this lesson. It's a solid block of Lego. If we measured each side, we'd find that each side is 5 centimetres long. So let's work out the total surface of this block of Lego. So there's the cube of Lego. If each side is 5 centimetres, then this surface has an area of 25 centimetres squared, as does this one, and because it's a cube, there are 6 surfaces, or 6 sides, or 6 faces to the block. So it's 6 times 25 centimetres squared, so the total surface area is 150 centimetres squared. Now say I broke it into 1 centimetre cubes. Okay? So how many 1 centimetre cubes would I get out of this? Will I get? In fact, I'm going to let you work that out for yourself. So the question is, a 5 centimetre cube has a total surface area of 150 centimetres squared. If it was broken into 1 centimetre cubes, what would the total surface area be? So we're breaking this larger cube into smaller cubes. The smaller cubes have a width, a depth and a height of 1 centimetres. What would the total surface area of all the smaller cubes be? While you're doing that, I'm going to get busy breaking this solid Lego block up into its smaller pieces so we can see just how much that increases the total surface, or the total surface area, when you break a large piece into smaller pieces. So pause the video now and answer that question. And welcome back. So you can see we're ready to do the experiment now. We've got the ground up with this pestle and mortar, the ground up calcium carbonate, so that's now in a powder. Remember, each tiny grain of this powder still contains thousands and thousands of calcium carbonate molecules, but because it's a powder, more of them are on the surface. And we've got the larger pieces of calcium carbonate here, which Poppy smashed off the larger stone. Now here, I've broken up the Lego block, and you can see that if I measured the surface area of every block and then added it all together, there'd be a much greater total surface area than there was with the original 150 centimetres squared and 5 by 5 centimetre Lego block. So, what's going to happen? Well, let's just go back to the theory. Calcium carbonate is reacting with hydrochloric acid in a boiling tube. Now the hydrochloric acid is in solution, so AQ for aqueous, and actually what's going on there is that because it's in solution, the hydrochloric acid is split up into H plus ions and Cl minus ions, IONS. So we've got H plus ions, and we've got Cl minus ions, and we've got calcium carbonate molecules. A reaction only happens when these things hit each other with enough energy to smash the calcium carbonate molecule apart and rearrange all the atoms. So if we're going to increase the rate of reaction, we either increase the energy of this stuff, and you do that by warming it up, or you increase the amount of those collisions that happen every second. You can increase the amount of those collisions that happen every second by adding more of the acid particles that means having a stronger acid, or having more volume of acid, so we're going to keep the volume the same, or by having more of the calcium carbonate molecules in total. So to make it fair, so that we know that we're just focusing on the particle size, we're going to keep the strength of the acid the same, the volume of the acid the same, and also the mass, the total number of calcium carbonate molecules by measuring the mass. So I've got here, also from the science prep room, it's great having a key to the science prep room. It's like a toy shop to a science teacher. A balance, a mass balance. So I'm just going to turn that on and tear it. Right, so let's do the experiment. We're going to put some of these large calcium carbonate pieces in here. Oh no, I need to weigh them. What am I talking about? Let's weigh them. So that's 6 grams, 7.04 grams, that's probably enough, 7.04 grams. That goes in there. Okay. And here's my powder. Oh, too much. 7.6, 7.32, 7.4. Excellent. Okay, and my powder is going in here. Should I get it all in? Fantastic. Okay, acid. Have to be careful with this stuff. It's actually quite strong, 1 mole of acid. So I'm going to measure out. Let's do 20 millilitres. When measuring liquids, you always need to keep your eye at the level of the liquid. So the meniscus, as it's called, doesn't give you a false measurement. And that's 20 millilitres. Okay, right. Can you see this closely enough, Matilda, or do you need to do a close-up? You ready? Okay, so 20 millilitres of 0.1 molar hydrochloric acid into large chunks of limestone, chalk, calcium carbonate. And there we are. Now you can see that that is reacting quickly. There is a lot of gas being given off. The gas is carbon dioxide. The last part of this lesson, you're actually going to write out the equation and you're going to try and balance it. So we can see how reactive that is. Okay, let's try the same with the powder. There we are. Oh, there you go. I think we proved our point, didn't we? The powder has a much faster reaction. The rate of reaction is quicker. Just give it a bit of a stir, a bit of a swirl, and it's still producing gas at a faster rate. So, same material, same strength acid, same mass of calcium carbonate in each, same amount or volume of H plus ions and Cl minus ions in each. The only difference was the fact that these larger particles was crushed up into smaller particles, giving them a greater total surface area. So what we've seen is how the surface area, which comes from the particle size. If you make the particle size smaller, the total surface area is bigger, and therefore the rate of reaction goes up. And that was good. Thank you. So the reaction is still going on. This one's slowed down quite a lot. And this one, if I give it a shake, there's still a lot of carbon dioxide being produced. So let's have a look at the reaction as a symbol equation. So we started off with calcium carbonate. We added hydrochloric acid. These are the reactants. And what has it produced? Well, we know it's produced carbon dioxide. And I'll tell you the other things it's produced. It's also produced water. Yes, it actually makes water in the reaction. And finally, we have calcium chloride, which is CaCl2. Oh, I've got hiccups, sorry. CaCl2, that's calcium chloride. So calcium carbonate plus hydrochloric acid gives carbon dioxide plus water plus CaCl2, which is calcium chloride. This is a solid, this is a liquid, this is a gas, this is a solution. So we'd write AQ if we were going to put the state symbols in, and this is a solid as well. Now that is not balanced. So what I'd like you to do now is balance that equation and think about what we should do next. There's several things we could do. We could carry on with looking at a limestone. We could talk about the formation of limestone, for example, and how that's come about. We could look at balancing equations. We could do more on rates of reaction. I could do some more reactions where we increase the rate of the reaction. Some of those experiments are quite fun. Not fun for me because I'm doing them, but maybe hopefully fun for you to see. So it all depends what you want to do. I've set quite a lot of work in the Google Classroom. Matilda, can you just pan down to show the Google Class code again? So, sign up to the Google Class, put that code in to where it says join, and do all the work that's in the classroom. It's not compulsory, it's just additional if you want to, and write some comments, and I will answer those comments and come up with the next lesson. So that's it for this lesson. Bye bye.